What is space junk? Let's get into it. Space junk refers to any object in space that is not in active use and that is man-made. So this includes debris from rockets, inactive satellites, and anything that astronaut has actually left out in space. The rubble could be really small, it could be really tiny, just like as small as a grain of rice, even small as just a dust particle that we can consider as space junk. And it can go up to maybe like an object as big as a satellite, because satellites are space junk when they're inactive, right? There are like around, just to put on some statistics, 36,000 objects that are larger than 10 centimeters, 1 million objects between 1 centimeter and 10 centimeters, and then around 130 million objects that are between 1 millimeter and 1 centimeter.
To put it in perspective, this is just a quick map of the space junk that's around the Earth, and the Earth is at the center where you see all the orange circling around it. But there's a legend in the top left corner so you can really see.
So you're thinking like, okay, if they're this small, why does it matter?
To put it into perspective, I'm going to use the example of a bullet, right? A bullet is a really small object weighing around, this 9mm bullet, weighing around 16 grains, which is 1 gram, basically 1 gram. So we're talking in the ranges of 1 gram to 5 grams for these bullets, right? How is something that weighs so small able to penetrate your body? Well, that's because of the velocity, right? Physics tells us that momentum is mass times velocity. So even though the mass is super small, it's moving at very high speeds that are around 3,000 kilometers per hour. So to really put it in perspective, that's creating a lot of impulse, and impulse is of course force per second. So a lot of force is going to a bullet.
So space junk is usually traveling at speeds of around 15,000 miles per hour. It can go up to 22 miles per hour. So these little small pieces of junk, small little debris, maybe small little pieces of aluminum, are practically bullets themselves. And we really don't want that to harm our satellites. What's kind of like a little avalanche effect is that, if a junk hits our satellites, right, and let's say our satellite gets destroyed, well, now that destroyed satellite has a lot more junk and debris and dust, small little pieces that is formed, and now these are orbiting, and now there's a higher probability of it hitting another space junk, another active satellite, right, and that becomes more space junk, and then the avalanche continues until like almost the whole Earth is just covered with space junk, and we won't be able to get any real satellite orbit. So that's kind of like one of the conspiracy theories, I would say. But it's probable. But it's one of the things we worry about when we're dealing with space junk. Now, I didn't say all that to scare you, okay? There are some solutions that I've explored, and I'm going to share it with you in this video, that are solutions to this, space junk. I would say it's a crisis, space junk crisis.
So the first solution is to simply burn the space junk. And how we do that is when a satellite is in a low Earth orbit, it's eventually going to slowly get closer and closer to the Earth until it reaches the atmosphere. And just like how for rockets, when they do reentry, they have to prepare the rocket so that it's strong enough to take the heat. Well, these satellites, they don't have that material, so they're gonna burn up as they're doing a re-entry into the atmosphere. The problem with this, right? The negative impacts would be that the aluminum from the satellites will bond with the ozone, and they'll actually kind of strip away from the stratosphere. So that's the problem, and of course that leads to more of the sun's ultraviolet rays coming to us. So that's like the major issue with this one. However, it's the most effective because it's the simplest. This is the stuff we're already doing right now. There's another part to the solution, and that is using satellites to throw space junk into the atmosphere and let it burn up from there. A video you see right here is a concept demonstration of ELSA-D, which is End of Life Services by Astroscale. Astroscale is the company that made these, and it would attach to a client satellite, which is an inactive satellite, right, or even space junk, and it would deattach it and kind of just throw it into an orbit that will send it into the atmosphere. And so it still has the same problems, or it works around the same way as, regular space junk being put into the atmosphere, which I'm going to talk about later. But it's actually really cool, and it's really cool technology. There's other missions such as Address-J, which is the acronym ADRAS-J. It's basically the same thing, same purpose as ELSA-D. It's all about the trajectory that it's throwing. So the next solution I have is to refuel the old satellites, right? And it sounds kind of crazy because how are we going to send a satellite to refuel another satellite that's in orbit? Well, trust me. NASA is working on a mission called OSAM-1, On-Orbit Servicing Assembly and Manufacturing 1. And that's what you're looking at right now, where it has this robotic arm that's going to use to attach to another satellite, and the other satellite that you see over there, the Landsat 7. And then from there, it's going to kind of cut into it and kind of do surgery on it to refuel it. And for this specific project, for the tech demo, it's going to put in a new fueling system that's easier to refuel. But that's kind of the gist of the mission. And there's other missions like the RRM, which is a robotic refueling mission, which has a module that has a bunch of different tools that the ISS is using to do stuff like this too.
So this is a really good working solution in theory, but it hasn't really been tested yet. So those are all like simulation videos that I showed you. Two of these, ELSA-D is actually being it's in orbit right now, and OSAM-1 is about to be launched pretty soon. So those two are going to be tried, but this is the first of its kind. The second thing I wanted you to think about is that it doesn't necessarily free up space. All we're doing is kind of decreasing the amount of space junk there is, because the term space junk is for inactive satellites. So by reactivating them, they're no longer inactive, so they're no longer space junk, but they're still there, right? So there's still kind of that chance of them getting hit by other space junk and then creating more space junk, with that whole avalanche that I explained earlier.
The last method is more of a preventative method. So what you see over here is the General Mission Analysis tool, and it is an orbital flight, a navigation and simulation tool, which is used where you basically put in like Keplerian data or any Cartesian data, basically of like altitude, attitude, velocity, all that stuff, and it will basically tell you the orbit path. And so if we're able to have an algorithm that puts in like where the space junk is being tracked, and then it could simulate that in the orbit path, then we would know where and when space junk might hit a satellite, and then we can choose a better satellite or choose a better orbit path so that we can prevent that from happening.
The big problem with the solution is that it's actually really hard to track those millimeter small space junk, space debris. So one method that there is kind of a counterintuitive, because we can only track them after they have a collision, right? So after this collision, because there are two pieces of metal that are moving so fast, right, it can create electric charge on the space junk. So through there, that's how we're able to track the space junk. Another thing that can be focused is adding more fuel to create more burns to maneuver around the space junk. ISS has done more than 30 maneuvers to avoid space junk. So maybe if we are able to do more maneuvers on regular satellites, we'll have less collisions. Though there's still problems with that, because it will require more fuel, therefore more weight, therefore less space or less mass for payloads. So there's pluses and minuses. All in all, the best way to really challenge and mitigate this space debris problem is to use all three of these methods. We have the space junk that's being burned up, and what's interestingly enough, there was a law that was passed. Not a law. There was a guideline that was passed by NASA to say that said that in the span of 5 years, inactive satellites, or like a satellite that's active, and these are for the newer satellites, right? If they're gone up, they taken all the data they need to be taken, they need to go down within 5 years. So the satellites are getting burned. We have our new techie ELSA-D. There's others like Astrad, ATR. SAD, I believe, from Astroscale. But these are all from Astroscale, the company. It's a Japanese company, by the way. But we have those high-tech satellites that are grabbing the space debris, throwing them in the trash. We have our OSAM-1s, our RRMs. We have our LEX from Astroscale, who are taking these new satellites that are going to refuel the old satellites so that they're no longer space junk. And then we track the satellites, implement those in our orbiting analysis, and find better orbits so that the chances of them crashing or being hit with the space debris is decreased. So all three of these need to be worked together. But most importantly, we need to find a better solution, because we can't rely on just damaging and burning the space junk in our atmosphere, right? First, that's resources that we had that's burnt up, and it's bad for the environment. There's already so many things that we've done to this environment. We don't need to do more. So all three of these is really the best, but then just finding a newer solution. But anyways, I hope you enjoyed the video. If you did, don't forget to give it a like, don't forget to subscribe. If you didn't, don't forget to like, don't forget to subscribe. If you have any new ideas that you want to see me talk about, put those in the comments. That's gonna be it. Ron to be out.